As long as the auxiliary equation can easily be factored, we can apply this to any order differential equation. So in example 5, we're asked to find the general solution to quantity d plus 4 times quantity d minus 3 times quantity d plus 2 cubed times quantity d squared plus 4d plus 5 squared times d to the power 5 acting on y equals 0. So let's first take a look at the order of this differential equation. So if we just look at the highest power of d in each of these factors, we see that the highest power of d here is 1. So if I look at the order, I have 1 and then d to the power 1, so that's 1. Then I have d cubed, so that's plus 3, and then plus d squared squared, so that's order 4, and then d to the power 5 is order 5. And so the total order of this differential equation is order 14. So that means when we look at our general solution, we'll need 14 coefficients. Now that seems very intimidating, but since this differential equation is basically already giving us the auxiliary equation in factored form, we can easily find out what the parts of the general solution are. So remember that d plus 4, that corresponds with r plus 4 in the auxiliary equation. So we have r plus 4 equals 0. And so the corresponding root would be r equals negative 4. And that then means that the corresponding part of the general solution is e to the power negative 4x. So now let's take a look at the next part, d minus 3, that corresponds with r minus 3 equals 0. And so this part gives us r equals 3, right? That would make that 0. And so if r equals 3, we now have e to the power 3x as part of our general solution. Okay, and now we take a look at d plus 2. That corresponds with r plus 2 equals 0, but there's a power of 3, so we have a multiplicity of 3. So first of all, let's see, our root is r equals negative 2, right? If you set r plus 2 equal to 0, we get r equals negative 2. And that means that our first solution will be e to the power negative 2x. But because of the multiplicity here, we have a multiplicity of 3. We also have terms with x and x squared. So that's x e to the power negative 2x, and then x squared e to the power negative 2x. So 3 solutions right there. And then for the next part, we have r squared plus 4r plus 5 equals 0. And again, we can use a quadratic formula, and we'll see that r equals minus 2 plus or minus I. And so that means alpha equals -2 and beta equals 1. So then our corresponding solutions in the general solution are e to the power -2x and then cosine 1x. That's the first part. And then the second one is e to the power 2x sine of 1x. But we have to be careful here. That's not the only answer here. We have the multiplicity 2 there. So we also have to multiply both of these solutions by x. And that means we get x e to the power 2x cosine of x, and then x e to the power 2x sine of x. And so the order 4 leads to 4 parts of the general solution. And then finally, we have d to the power 5, and that translates in terms of the auxiliary equation to r to the power 5 equals 0, or r equals 0 by taking the fifth root on both sides. But keep in mind that this has multiplicity 5. So with r equals 0, then our solutions are given by the basic solution is e to the power 0x, which will simplify to just 1. And then the second one is e to the power 0x with an x in front. And then we have x squared e to the power 0x. And then we have x cubed e to the power 0x. And when do we know when to stop? Well, this is multiplicity 5. So we need 5 basic functions here, and we have 1, 2, 3, 4. So we need one more. And that means we end up with x to the power 4 e to the power 0x. And again, all of these e to the power 0x just becomes 0. So we can simplify that to 1x, x squared, x cubed, and then x to the power 4. Okay, so we have all the ingredients, and let's put them together in the general solution. Y of x equals c1 e to the power -4x. That takes care of this, plus c2 e to the power 3x. That takes care of this one right here. And then we have c3 e to the power -2x. Sorry, this is a plus. That's a plus. c4 e to the power, sorry, forgetting my x there. c4x e to the power -2x plus c5 e to the power c5 x squared e to the power negative 2x. So these first 5 terms take care of these solutions here. So now we have these 4 solutions here. I'll continue that on the next line. So that's plus e to the power 2x cosine x plus, and that's then c6 plus c7 e to the power 2x sine of x plus c8 x e to the power 2x cosine x, and then plus c9 x e to the power 2x sine of x. So that second line takes care of these 4 functions here. And then finally, the last line, we're up to C10 as our coefficient. C10 times 1 plus C11 times x plus C12 times x squared plus C13x cubed plus C14 times x to the power 4. And that is the general solution to this differential equation.